Hello and welcome to A Theory of Everything. I'm Luis Razo, the director of ASEM and host of this channel. Today I have the honor of talking to Adrian Bejan, the J.A. Jones Distinguished Professor of Mechanical Engineering and Applied Physics at Duke University. Among his many accolades, Professor Bejan was awarded the Benjamin Franklin Medal in 2018 and the Humboldt Research Award in 2019. He's ranked among the top 0.01% of the most cited and impactful scientists in the world and top 10 in engineering with an H index of 101, which is pretty amazing when a 60 is considered exceptional. He is the author of 30 books and has more than 79,000 citations on Google Scholar. We talked about one of the central tenets of this channel, the fundamental role that physics plays in evolution, and about his discovery of something known as the Constructal Law. Sometimes it's a little hard to follow the professor, but it's worth the effort because he communicates some deep ideas. One of the most important, in my opinion, is the idea that freedom is ultimately governed by physics, which is very much aligned with a recent video I published on the physical foundations of morality. If you watched that video and were skeptical, I encourage you to pay it another visit in light of Professor Bejan's award-winning work on the Constructal Law and in light of our exchange on the topic here. This is all very promising because it moves things like freedom and morality away from philosophy and theology into the more testable and less controvertible domain of physics. Think about what I'm saying. It's an extraordinary claim, sure, but it's something worth taking seriously. One thing we did not get to talk about is the connection between the Constructal Law and gravity, if there is one, and how we can use these principles and the underlying math to resolve some of the biggest open questions in economics and voting theory. I haven't covered this yet in detail, but I will in another video. The good thing is Professor Bejan has expressed a willingness to come back, so we have these things and much more to talk about in a second round. Like always, you'll find a timestamp in the video description. And like always, if you think I have something all wrong, let me know and I'd love to have you on as a guest. Thanks. Professor Bejan, you're presumably in North Carolina, somewhere near Duke, and I'm in Barcelona. Welcome to the channel and thank you so much for taking the time to talk.
Thank you. Thank you very much for the invitation. I'm at Duke. In fact, I'm in my office. And I've been in my office throughout this pandemic. Of course, I've been here safely, but the point is that the professor lives in his niche, and this is my niche. Okay, I'm surrounded by more of me here. So,
excellent.
What would you like to talk about?
Well, there's several things I'd like to talk about. First thing I'd like to say is that the name of this channel is A Theory of Everything, partly because we cover a lot of different topics, but partly also because it's a play on a term that comes from physics about the connection between fundamental physics and, in principle, everything else, from chemistry and biology to psychology and presumably to society. Today, we're not going to talk about fundamental physics per se, but we are going to talk about an aspect of nature that is certainly fundamental, and it's about your discovery of something known as the Constructal Law. I'll try to explain what that is in a minute, but first I'd like to let listeners know that we're going to divide the discussion as agreed in two parts. In the first part, we'll go over the actual science behind your work and your discovery of the Constructal Law. Maybe we can talk about the original paper, your work prior to that, leading up to the discovery, maybe your experience in academia, which I think could be very interesting. Then in the second part, after we've laid down the actual science, we'll go over the implications of that science for things like ethics, democracy, politics, philosophy, etc. Does that sound like a plan?
Sounds good. Before you begin, let me react to this theory of everything. Today's discussion is not about that. In addition, I take the search for the theory of everything with a grain of salt. It is an important discussion to have about people's lack of success in that direction. It is that the theory of everything, like for example, the tendency toward discovering our subject today, meaning the laws of physics, it is a human tendency toward condensing what is known. This tendency, of course, is useful because it makes the book thinner and the backpack lighter. But the important thing to notice is that science has the tendency toward establishing for itself a hierarchy of what scientists believe is true, and that is a hierarchy of belief. And this is where science, in fact, circles back unwittingly to its origin, which is religion. That's the important thing to keep in mind. In other words, scientists everywhere, or the scientists of everything, look more kindly at the other people around you who have not studied these things. Okay? So that's the grain of salt. The grain of salt is the size of a boulder, if you want.
Okay. Well, let me see if I've understood you correctly. Because I was kind of thrown off by the reference to religion. Are you saying that the theory or the quest for a so-called theory of everything in physics is something like a religious impulse? Is that what I've understood correctly?
No. I'm referring to the evolution of both, with religion evolving earlier than science.
Okay.
It evolved from polytheism to monotheism. The monotheistic religions have developed for themselves today, rigid hierarchies that are useful for the flock. And it's the same way with science. If you look at the science, the free-for-all that was during the time preceding Einstein, to science today, which is in fact directed by the funding agencies. That's okay. And the more hierarchical than the government, I cannot detect today on the landscape. So, but the important thing to notice is that this phenomenon of evolution, in this case, the organization of those who know how to get together and listen and read and write, this thing is a phenomenon with a long history. Religion, in fact, emerged, for the purpose of empowering the individual, a more and more useful and accessible interaction with the nature around the individual. That is the origin of religion. And of course, that led to belief and confidence in a few things worth knowing. Well, the same sort of tendency or urge led to this activity that's outside of the temple, which is called science.
Very, very
Simple
good.
as that. Yeah.
Okay, very good. Well, how about if we begin with a description of the Constructal Law? Can we begin with that?
Sure, yeah. First, law in the beginning is the individual looking around, observing, and trying to make sense of the perceptions. the good news about us is that when we see things that repeat themselves the same way many times, we categorize that as a phenomenon, as a apparition of a happening. And after many phenomena observed that are observed, then it's become necessary to condense one phenomenon in one dictum, one little statement. That little statement is the law of physics. We have most recently for mechanics, Newton's second law of motion, but in thermodynamics, since 150 years ago, we have the first law and the second law. The first law is the aha, that the energy is conserved. The second law, another distinct aha, that things by themselves flow from high to low, which is called the phenomenon of irreversibility. Note here, I'm not using the word entropy because it's completely unnecessary. In fact, it's counterproductive in this course. And so knowing these things, it occurred to me that nature, this thing, these perceptions that inundate us are full of images, configurations, and not only that, but morphing images. This thing is called design or drawing or cinema, if you want. And if you know the history of anything you want to name, the history of river basins or the history of human movement or technology, you know that. Sorry, much simpler. The history of as we know it, of animals and the biosphere and all of that. Then you realize that these configurations have been changing over time in a discernible direction. And that direction is that everything that flows, like the Danube, which I grew up, is throbbing and struggling to flow more easily from the plain to the Black Sea. And that's the aha that, this powerful science we all use and depend on could benefit from an add-on, a new aha called the Constructal Law, which states exactly what I said, which is that any flow system that has freedom to morph must, in order to stick around to be observed, must evolve to provide greater access to what flows. And you can fit in this any meaning you can fit in the shoe any foot you want. Fluid flow.
Does this apply? I'm sorry. Does this apply to, for example, galaxy formation, or at what level does the law apply? At all levels, at fundamental levels, at quantum levels?
Well, it's up to the questioners or the skeptics to widen the tent that covers all these applications. Clearly, my group has done a lot of that. Today, this is now 25 years later, there is a worldwide movement on this particular topic. They've tried all sorts of things, sea corals, the lungs of mammals, the mounds of termites in South Africa. That is in addition to the things that I've published. So, and yes, on a whim, about I think it was 4 years ago, with an undergraduate who was taking my constructal course here and was doing a double major in astronomy. We looked into celestial bodies, and we showed that this constructal law accounts for the fact that celestial bodies should be of hierarchical sizes, not of one size, because after all, the celestial bodies come from this suspension of solid, the primordial soup, coalescing into bigger globules because of the mutual attraction of these small bodies. And that phenomenon of it's a movement, of course, it's a flow, it's volumetric, it's distributed, let's say, uniformly in the very, very beginning, has two choices. One is to coalesce uniformly into bigger and bigger things of one size. And the other one is not to do that. And we show that coalescing into hierarchical bodies happens faster. Because if you take this constructal law in an isolated system, not a closed system, it's an isolated system, which is much more restrictive, then this constructal law tendency is can be stated more precisely as the evolution of that configuration, meaning that drawing, more rapidly toward the final death state, which is called the death of that isolated system. So the latter, meaning what I just spoke, is known in the physics, of course, but what is new is the evolutionary design or the movie on the way to that imagined end. Anyway, the way to that imagined end is the construction. Yes, the construction of a hierarchical movement in that isolated chamber. That's it's like lightning in the same isolated chamber, bringing two parts of the chamber from a initial state of non-uniform potential. Bang, the way to, let's call it death or equilibrium, is the hierarchical flow that everybody could photograph and admire. That's what you brought up. But we did publish what I just told you in a physics journal. So that's quite a feat coming from people like Adrian, who were trained in thermodynamics in engineering.
Very interesting. You mentioned hierarchies, and we'll come back to this in detail, but something came to mind. You say that nature organizes itself according to hierarchies. And I think, if I understand it correctly, that makes a lot of sense. But something that I've always been stuck with mentally is the bell curve. Does the hierarchy have anything closely, or is it associated with the bell curve, or is it completely different? Or can you elaborate on this?
Okay, if I forget to talk about the bell curve, please remind me. But I begin with the beginning, which is that you claim that the constructal law proclaims that nature should be hierarchical. No, the constructal law that I stated is about basically the command that for a flow system to persist in time, it must have freedom to morph to provide greater access to what flows. There's nothing said about hierarchy in that. Hierarchy is one configuration, evolutionary design, if you will, that emerges if the flow is from an infinity of points, such as an area or a volume, like the river basin, to one point. That is when you get the hierarchy.
I see. Okay.
All human movement is like that. But if the flow is between 2 points, as in one channel of that river basin, then you end up with the channels of the river basins you see all over the world, which are shaped in cross-section such that the wide river is deep. The narrow river is shallow. You can step in it. And so that's or for that matter, the blood vessel is round in cross-section. No hierarchy there. It's just one drawing that spells Constructal Law is alive, okay? That's the, and there are many, let's say, simpler drawings, such as the fact that in that said hierarchy, you have branchings and pairings. Well, that's number 2, dichotomy. That number 2 is predicted if you invoke the Constructal Law in laminar flow. But if you change the language to turbulent flow, you end up with number 4, which is of course measured in all the river basins in the world. It's a number 4 that's not exact, because the Ganges is not to be confused with the Mississippi. However, on an average, a mother channel has 4 daughter channels. And from this, I arrive, okay, without trying, at your bell curve, which is that if you plot the number of daughters, you count all of them, large and small, you find that they organize themselves into an ant mound that looks like a bell curve, the peak of which, meaning the average, is at 4. And then you have outliers, not very far, but you have a body of let's call them relatives of those daughters that are not exactly equal to 4 in number. Well, that's nature. Nature, in fact, everything that comes from the thin book of physics, which is predictive, is met with, let's call it approval wrapped in chance. And the chance has to do with the fact that in some places, in this example with the river basin, some places the ground is full of rocks, or the river has to get around a mountain, and excuse me, or an earthquake, a cliff, a waterfall, and all these other things. The point is that the environment, meaning the niche of this thing that's called flow system, is brings diversity and also randomness. You don't know what's going to happen to a particular place or a particular group of animals tomorrow. You know, plague or hunting or the introduction of a new predatory species, or for that matter, a zoological experiment that then runs out of hand. You don't know.
So I have a question. Why the name? What is Contractal Law? Where does it come from? How did you come up with it?
Constructal Law, correct. Well, the Constructal Law right here at this table was a joke played on me by, I had at the time, a Brazilian student, highly gifted in making drawings. He and I were, in fact, having fun with that. And early on, that's in 1995, when I was simply drawing these things, yes, let's call them a tree-shaped, I was in fact predicting them, tree-shaped flows of water, of heat, of people in the city. He comes to me with his accent, telling me that that these some of these drawings are in a book called The Fractal Geometry of Nature. This is a famous book by Mandelbrot. My luck in life is that I'm not a very good reader, so I was unaware of that. I asked him to bring the book, and when I opened it at, I think it's page 30 or 33, I read that this mathematician who grew up in Poland and then France, he invented for this drawing that looked like broken sticks, from big to small, fractal, which comes from frangere in Latin, which means to snap a stick or a dry bone into 2 smaller pieces. And I said to Marcelo, hey, listen, this man took the wrong word, or the wrong verb from Latin. The correct one would have been construere, because nature does not break things into smaller and smaller things all the way to dust, because fractal objects
very interesting, very interesting.
only in the imagination of the mathematician ad infinitum. Read the book. No, nature does the complete opposite, which is why nature is visible. It constructs things. In fact, the river basin tells you, it takes silt from here and puts it over here. That's called erosion. In the geophysics, people talk about erosion. They spend less time talking about deposition or construction, you see. The visible thing is the construct, the new thing. Even the mine where people mine for minerals, those deposits came from somewhere. Previously, they were flow systems, you see, they were not dead. So everything that is either flows or it had been flowing to the place where you see it. Sorry to make it even more obvious. Visit the cemetery, all right? Nothing moves, but what is in the cemetery is a record of a lot of movement. And a
That's
lot
interesting.
of movement.
May I ask you about that? Because your constructal law is a law of evolution and a law of movement. So I couldn't help, as I was reading through your material, to ask how it deals with death in things, and death in people, and death in general. How does death fit into the picture conceptually?
Well, that's very interesting, because death ceased being an enigma when thermodynamics was born. In the thermodynamics, the entity that's being discussed is called system. It's most general. It's a black box with a precise, unambiguous definition. We draw a boundary, which is imaginary, a boundary around this block of cheese that we're discussing right now. So that system is said to be in the dead state. That's the word used in thermodynamics, dead state. If in that system nothing moves, nothing changes, nothing morphs, there's no deformation of what you're looking at, that is the dead state. Nothing, nothing, nothing. Well, if you delete the word nothing, then the state of the system is the live state. And this is the white and black, or the male, female, that I am proposing to all of us to recognize, that if there is a dead state in physics, then there is also the live state, which of course is all over physics, because in physics, say thermodynamics, we have a process. Process is the change of state. Clearly, that state that engages in having change is live state, or from one life state to another, or through an infinity of life states, a movie, if you want, and that needs to be called in the same common language as the dead state was called. And so that's the answer to in other words, everything around us, including the things that are found buried, are live, or at one point in time, they were live systems.
Yeah, very interesting. Now I forget, I had just thought of something, but I forget it. Maybe I'll come back to it. And how did you arrive to this? Tell us about how you came to it, the first aha moment. Was it a long process? Was it a lifetime thing?
First of all, let me finish the joke. So I said to Marcelo, this thing, the so-called geometry of nature, is not fractal, it's constructal. By the way, Marcelo speaks Portuguese, I speak Romanian. They're very, very similar. We laugh when we interact. And that was a good joke, which turns out to be so good that people now repeat it, okay?
It's a good one. It's a very interesting story.
look, I'm an amateur. I was not educated to rub elbows with evolutionists, you see. But evolution, by the way, evolution really means change, means a change with discernible direction. You can check the dictionary. In fact, evolution literally comes from the verb evolvere, much older than anything that we're discussing here. This is, Roman and pre-Roman mental viewing. Evolvo means rolling out forward. Well, that's the image of childbirth. Out of whom? Out of natura, nature, the only mother of everything. That's a fairly simple description of everything that is. Pretty good language, this Latin, you see.
Yes.
So that was, in fact, not the original aha. The original aha is that I had all these drawings that I was doing because of the way I think. I'm not a philosopher or whatever. I'm just having fun with my violin, okay? And then I was at a thermodynamics conference in Nancy, France.
I'm sorry, Adrian, you lost me a little bit. You said you were drawing and then you were playing a violin, or did I hear?
No. Okay, sorry, I was mixing thermodynamics with metaphors here. I was having fun with my work. I was predicting drawings in order to configure the easier flow after obviously considering many options, meaning morphing my drawings on the white page of my mind before
May I pause you quickly, very briefly? I know that you had a very important impact on how computers are kept cool.
Oh.
Is this related to that, or is this before that? Is this at the time?
Yeah, an activity at the time was basically to invent, to figure out how to suck heat out of a box, which is the name for cooling something like a laptop. The laptop generates heat, and that heat has to be vehicled out of the box. In the early 90s, the boxes were bigger. So it occurred to me that obviously you pull the heat out by sticking your hand in it, which meant to endow the guts of that box with high conductivity paths. And so what was left was to figure out the better and better arrangement of these fingers and ramifications of high conductivity roots in the fixed volume. And the drawings were emerging, pencil and paper. This is, like an antiquity, all right? And they were not only emerging, but they were beautiful and worth talking about. I was getting ready to publish them. Anyway, I had them on my table right here. And then at this European thermodynamics conference, the banquet speaker was Ilya Prigozhin, who had gotten the Nobel Prize for chemistry in 1977. And being brought up in Romania, I knew French. He spoke in French, so he said in his speech toward the end that configurations that are arborescent, meaning trees and lightning and rivers, are aléatoire, which means the result of throwing the alea, the dice. I'm a nobody at the end of the amphitheater, but I said, oh, wow. But my trees on my table here are really not the result of throwing any dice. I was simply invoking an idea. And obviously the idea that I was invoking because I was educated, unlike him, at MIT in engineering, is this. So I wrote it down on the plane coming back from France, and that was the Constructal Law.
Wow.
Yeah,
Very, very
simple as
interesting.
that. Simple as that. Look, which, by the way, if you if audience, if you have young listeners, when you hear a Nobel laureate, obviously with the great respect and admiration, pay attention and feel free to question and compare what you hear with the music that is playing in your mind. Just go through that exercise, and you'll feel much better about him and about you. Yeah.
Excellent. Great advice. Great advice. And can you tell us about once the idea germinated and you had it clear, you wrote a paper on it, how was it, the process of getting it out there? Can you talk about that? Was there a lot of resistance? Was there immediate success?
I think it was closer to the immediate success in the sense that nobody shot me. I was, because you see, yeah, absolutely. In science, a new idea is captured by the image of the courageous kid who climbs on a limb, you know, to the end of the branch to pick the unpicked fruit, and then falls to the ground, and then climbs again. That's basically research. And the fall to the ground is, of course, the punishment that happens to the person that climbs on a limb. So yes, I climbed on a limb. I was not punished. It was fun to climb back and do it again. But I discovered very early that I was not alone for two reasons. Some colleagues, in fact, a lot of them, mostly from with my background in European education, joined or started to do this kind of work, competing with me. That's one thing. The other phenomenon was that students came to me to study this sort of thing, to do PhD theses, to be in my, I've been teaching an undergraduate course here for more than 20 years. So I thank Duke University for making a home for constructal design, which is a better name for what we're doing as creators of useful things.
What do most of your, I'm just curious, what do most of your students go on to do? Do they go into science, mechanical engineering, drawing?
The students at Duke or my own students?
Your own students, yes.
Well, my PhD students, almost all of them end up being professors in universities worldwide. That's the, I can answer that. Duke graduates are highly successful in all directions. This is something for the university to trumpet. In engineering, my impression is that our graduates are everywhere, mostly in the industry. A big percentage end up in like on Wall Street and these places that could employ young people with training in the you know, thinking in the abstract and predicting things through you know, algorithms and such empowering tools. So Duke University is a very big locomotive on the landscape of success.
Excellent. One more question, and then we'll switch to the social implications, if it's okay. Can you tell us about the highlight of your career thus far?
Highlight?
Yeah, the highlight, maybe the best moment or the happiest moment or particularly satisfying event?
The highlight is that I keep going at the same level and with the same rhythm as I remember myself throughout my career. That's the highlight. I would call it. This is now coming from sports in which I was raised. The highlight is that I continue to be the player that I was meant to be. I am not
Excellent.
slowing down. I'm ready for the next, boxing round. I'm not falling asleep. I'm quite the opposite. Ready to question authority. How is that?
Excellent. So you excelled in basketball. Do you feel like the discipline that you had in basketball remains the same? Has it been a life lesson for you?
Well, only in retrospect, I pay a lot of thanks to that upbringing. In my case, it was great fortune out of misfortune. My father was chronically ill, so I was without a father for a long period, exactly when I was in my teens, all the way to age 20. And fortunately, our house was adjacent to the sports fields of the city. And there I was the kid, the ball boy for everything. I learned to play all these things you see at the Olympics. And the basketball team adopted me because they were storing some of their equipment, including the balls, in our house. And so that's basically how I became a player, and I excelled at that. In the movie that I just sketched came the necessary discipline, that of training, not exactly every day, but training regularly, and being punctual and having program, and not exaggerating in the training. In other words, balance in the program. And that was extremely useful because at the same time I was getting trained in mathematics. I had an inclination in that, in the communist camp. Mathematics Olympiads were the #1 game for those who could not play basketball. So training for the Olympiads in math was benefited greatly from the work habits that were injected in me while I was becoming a player. And so that activity is what I've done all my life. People ask me, how could you write 30 books and 700 journal papers? And I'm not a maniac, but I do work, meaning I'm always in training, okay? And a lot of this I do alone, like the Michael Jordan alone with the ball at midnight in the arena because there's nobody around him then. That's what I do. It's
that's impressive.
Very useful, very useful, very
That's
useful.
impressive.
And incidentally, here, let me give credit to the man who invented sports, the way we practice them and applaud them today. Pierre de Coubertin, the founder of the modern Olympics. He actually created physical education, what is now in every school on the planet. And he was the champion of that in order to create a way to raise, in his time, it was young men, to be dependable and responsible and all of this, young men, without the weapon in hand. So he wanted to have a new generation of in this case, Frenchmen, who are not raised to become a cannon fodder for the next slaughter in the next war. And only to promote usefulness of this invention of his, he created the Olympics as a gimmick, as a advertisement. Well, the ad worked, but the product is even more useful because it is practiced by everybody. But the essence of the usefulness of the product is the same as in the military, which is that it forms strong, dependable, obviously law-abiding, and also correct human beings. That's the product, and that's in sports. That, by the way, is I think the mission of the university as well, in all the things that the university teaches. And I'm not shy to point out these things that to me are obvious and very, very useful.
Excellent. Well, you mentioned communism, and I think this would be a good point to transition to the social implications or the philosophical implications. I noticed that your work is very attractive and appealing to people who espouse free markets. Can you tell us why you think that might be the case and how you feel about, for example, a communist regime versus a capitalist or free market regime?
Well, I welcome to this discussion anybody who is interested. It is true that, meaning the observation that those who are interested in, say, freedom are attractive, obviously, because you cannot have change in this evolutionary design unless the configuration is free to change. That too, by the way, is nothing new in physics. A thing, again, system that changes must have at least 1 degree of freedom. The cylinder with steam inside and with a piston, this is the embryo of thermodynamics. That drawing has freedom to change because the piston could slide in and slide out. You see, that's a rectilinear motion between 2 positions, and that was freedom. So freedom belongs in physics as a property of a system, the same way that the pressure, the temperature, the volume, and a few other important words belong in physics. And this is the subject of my most recent book called Freedom and Evolution, because evolution is, well, if you're really curious, it's actually synonymous with the freedom to change. And now in this comparison that you bring up, free market versus communism, the difference is pretty obvious. Free market happens. Communism does not happen naturally. You see, communism is dictated from above by one individual, by one manifesto, and by more and more preachers from this hierarchy that grew under the likes of Marx, Engels, and then Lenin. And then, of course, it was implemented as Mao then proclaimed through the barrel of the gun. All right. So, and when it comes to social organization, which is really the design of a live flow system, the society itself is not particles jiggling in a box. The society is river basins of people flowing on top of river basins of other people, where communications, where power, meaning electric power, and sewage, and U.S. mail, and whatever you want on the area. In this live flow system with evolving configuration, the chief property is freedom to change. and that freedom is the physics. And if when you install obstacles in this architecture, just like the levees in New Orleans, the river basins naturally revolt against those obstacles and remove them. You throw a log across a river channel, and next month it's gone. It's simply gone. Or a bridge that falls into the river is gone. That's the power of obviously the life flow system, and that direction of change from obstacle to no obstacle is the result of the fact that the architecture is free to change. And that is
that a good summary? Is that a good summary, a good way to think about the constructal law? That in the end, obstacles must give way to freedom? Is that a correct way to? Okay.
Absolutely, but not only that, the obstacles are then deposited somewhere else where they may be useful. And of course, if you want to go now to the Danube Delta, all this debris is carried to the delta, where it becomes very useful for the purpose of feeding this ecosystem or feeding this other ecosystem, or for doing wonderful things for the climate. That's the way it is, the hand in glove of flow inside of flow inside of flow. All right, but going back to communism now. So the fact that communism as a world phenomenon demonstrated in the 20th century is that its demise is a reflection of the Constructal Law, meaning that I wasn't living in science to predict it, but by the fact that it expired as it was designed originally by these dictators, that shows once again that freedom is the F word worth knowing. And worth pronouncing from, screaming from the rooftops. This word instills fear in the dictators. This is why the life of any dictator is short. Every dictatorship or every obstruction of human flow on the landscape is destined to be adjusted, if not eliminated.
That's very interesting. This reminds me that I'm going to put a link for listeners on the screen. I recently put out a video arguing that in the long run, ethics has a physical foundation. Ethics or morality has a physical foundation, largely for the same reason, because over time, that which continues to exist is more moral to the extent that it exists longer. Would that be something related to what you're saying?
Absolutely. I totally, obviously I agree, because as I said, I was educated in Europe, where these things are well known. The difference between right and wrong is akin to knowing what happens to you if you jump off the balcony.
Sure.
The right versus the wrong. One option is good for you, which means you don't jump, and the other one is fatal to you. All right.
Sure.
So this dichotomy again is the fork in the road where science is very helpful. But before science, as I said in the beginning, religion was the helpful doctrine. Today we have both, by the way. We have both. This business of respecting your parents and your elders and listening to them is the same sort of book that empowers you to know the difference between was good for you and was not good for you. Absolutely. And ultimately, science is about you,
Exactly.
the user of it.
Sure.
That's
And
why
I would say that applies. I'm sorry. I would say, or I would ask if that applies, or I think the answer to this is quite obvious, but this applies at the individual level. So if I jump off of a bridge, obviously I'm not going to survive, no, but it also applies at the group level and at the maybe nation level or ideological level. Would you agree
no,
with that?
I would stop at the individual, and then you and I will arrive at this unplanned discovery of where the dictator comes from. At the individual level, this let's call it wisdom, is very, very helpful. And another bit of wisdom is the fact that it's easier to move through a crowd when surrounded by others who move in the same direction. In other words, social organization is a phenomenon that happens because of the what's good for every individual that joins. You see, you don't see solitary, hunters and gatherers anymore. They've learned along the way to have settlements and to have obviously village and then city society and all this. Not to mention the trade and the language, of course, and the religion that connects them even more tightly. The point is that the social organization, the mother of that is the urge of every individual. And it happens, the organization happens when the individuals find, again, without trying, that there's a consensus among them, a consensus to build a street here or to build a courthouse over here. So consensus is this, let's call it coincidence that's known only after the fact, which is after the fact is when the group equips itself with a large-scale thing called a village or something else. So that's the social organization. And then, step by step, there's this phenomenon of hierarchy with which our discussion began. And every once in a while, at the top of the hierarchy happens. I mentioned the randomness and chance earlier. I'm not ruling that phenomenon out of existence in this entire discussion. At the top of the hierarchy emerges a charismatic person, maybe one who writes and speaks better than others, or maybe looks better than others, and we have names for these individuals. Tribal chief all the way to king, and then the examples of the 20th century. And these minds at the top could be of one kind, such as George Washington in the United States, or another kind, Mussolini and Hitler and others, all the way to the ruler of North Korea today. And meaning this, the latter are the hiccups for the tree logs that fall across the river. That's the physics of social organization in time-dependent fashion, meaning with hiccups. But if you look at the evolution of human organization, meaning all of it, you see the Constructal Law in very bright colors. It has been decisively toward greater movement in every respect, not only in place, from sliding things on the sand to the wheel, and then obviously domesticated animals such as horses and oxen, all the way to the steam power and everything else that makes us unbelievable human and machine specimens today. So that's basically our story, and our story has been toward greater movement, but also toward much greater freedom to move, freedom to meaning to also to move to change a country and continent, freedom to change our minds, freedom to change our minds, freedom to change our names, freedom to change our languages, from the maternal to the to the language of the new world. These things.
That's very profound.
And also freedom to change the religion. That is worth keeping in mind. Just like in a good ball game, it's one thing to be fixated on the ball. It's much better to keep the whole playing field in view, especially the playing field that's ahead of you in time.
Okay, well, listen, we could talk about this for a long time. I hope you are receptive to come back at some point. I want to be respectful of your time, Adrian. Thank you so much for the time you gave us today. I'd like to draw readers' attention to your most recent book. You said you've written more than 30 books. Is that the case?
Yeah, sure. They're all lined up under my window. Watch there. See that?
That's incredible. That's incredible. Well,
and by the way, they've been translated into many languages.
Wow. Well, your most recent one is Freedom and Evolution, correct?
Right.
Is this the one that does it have a special place in your works in general, or how do you feel about it?
Well, every single one is special, but they're related. They're in fact scene after scene in a movie of my own evolution as a physicist rooted here in the thermodynamics of engineering. It's about being happy in my work. By the way, I draw attention to aspiring professors. I'm one of the, I think, few who are not repeating what they were taught by their advisor. In other words, I used the original momentum, of course, but I moved in my own direction. So it's about doing the kind of work that you do, which is to hear your own calling and then pick up that violin that belongs to you, and not to somebody else. That's fantastic.
Fantastic.
That's what that lineup of books really is. By the way, Freedom of Revolution is being translated right now in Japanese. Yes.
Wow.
Yeah.
Wow. Very nice. Well, congratulations. Congratulations for that, and for your lifetime of contributions to science and to your students, and for the little bit of time you gave us today. A great gift for everybody. We appreciate it, and like I said, I hope you'll have time to come back at some point.
Sure, I'm easy to find.
Okay. Thank you very much, Professor. Bye-bye.
Take care. All the best.